go over this real quick.
No, I'm being dead serious.
All right, so here we go. If you didn't know how to do it, this is your chance to catch up. We are going to do these problems. Here we go. The first one, we take 1 times -5 and 3 times 2, and we subtract them. So -5 minus 6. How many got -11? You are right on target. If you had done your homework, you would have practiced several of those, and it would have been so easy for you. Now, the 3 by 3s, the 3 by 3s, we recopy the first 2 columns. And then we multiply, and multiply, and multiply, and total that up. So we multiply those numbers, multiply those numbers, multiply those numbers, and add them up. Then we multiply these, and these, and these,
My eyes are ready.
and add them up.
You will not believe this.
And what do you do with those 2 numbers? Subtract. So the answer to that one was
Okay.
1. How many got that one right?
You may not believe me, but I actually have both of the right answers. Second guess myself, completely laid a brick on that quiz. like I'm not lying. Like I actually have both the right answers. Second guess myself, and I pretty much just exploded everything inside of that quiz. So don't let that quiz reflect my intelligence or my grade in this class.
Okay.
So just pass me if you like.
All right. Problem or backside of note sheet 45, problem number 4.
Next quarter is going to be hard.
We have one skill to learn today. We're going to find the inverse of 2 by 2 matrices. You will understand why later, but right now we have to master the skill. So here we go.
What? You said 3?
I am on the back side of note sheet 45. And I'm doing problem number 4A. I am going to find the inverse. This is called the inverse. It is a 2-step process. The first step is find the determinant. You know how to do that. The determinant, this is step 1, we have to find that determinant. What is the value of that determinant? 5 minus -2, which would be 7. So when you write your inverse, you start by putting 1 over 7. So whatever your determinant works out to be, you start with 1 over that. All right? And then you're going to create a new matrix. And creating a new matrix is easy. You take these 2 numbers, look where I'm pointing, these 2 numbers, and you switch them, literally switch their positions. So whatever you have here comes here, whatever you have here comes here. These 2, you switch their signs. So if it's negative, it becomes positive. If it's positive, it becomes negative. So one more time. We do 1 over the determinant, and then we make a new matrix. And to make the new matrix, we take these 2 numbers and switch them, and we take these 2 numbers and make their signs different. So if it's positive, it becomes negative. If it's negative, it becomes positive. Okay? And then we distribute. We do our scalar multiplication. So we take 1/7 times 5. What will 1/7 times 5 be? 5/7.
Oh, never mind.
And -2/7 and 1/7 and 1/7. Now, after we've done a few, we'll talk about what we're going to use this for, but right now, we're focusing on finding the inverse. So there's our first one done. Let's look at the next one and see if you can remember what we did. Okay, we're finding the inverse. It's a two-step process. What do we do first?
The determinant.
Find the determinant. So here you go. You know how to do that. What's your determinant going to be? 4. But we don't write 4, we write 1/4. Now, did everybody get 4? It's 1 times 4 minus 0 times -3. So it's 4 minus 0. Now we're going to build a new matrix here. So we take these two numbers and do what with them? So we put a 4 and a 1. And then we take these two numbers and we change their signs. Now 0 is just 0. But this negative will become a positive. So then we do our multiplication. This first one's going to be 4/4, which is just 1, and 3/4, and 0, and 1/4.
That's it?
That's it. That's the inverse. That's all there is to it. Let's try the next one. This is the only thing we're learning today. Then we're going to look at why we have some of this stuff. All right, so here you go. Your job is to find the inverse of this.
110.
So you started with 1/10. I need to hear agreement or disagreement. Is
Disagree.
1/10 correct?
Yes. If you disagree, you're incorrect. You're wrong.
Now, if you disagree, we need to talk about it. All right, now what? Now I'm going to make a new matrix, right? Abby Brady,
Hold on, wait.
what do I do with these two numbers, Abby Brady?
Switch them?
Yep, so the 3 goes here and the 2 goes here. What do I do with this 4, Abby Brady? Okay, somebody help her out. She remembered that we switched these two numbers, we changed the sign. So this becomes a -4, this becomes a +1. We leave them where they are, we just change their sign. All right, here we go. So now what will go right here? 3/10, 1/10. Now watch it. This will be -4/10.
Can't you reduce it?
But what about -4/10?
2/5.
All right, I'll make another step just so we're not going to. That's going to be -2/5. And what about 2/10? 1/5. So there's our inverse totally reduced.
So do you have to totally reduce it?
Yeah. There's one more example. Do I have a volunteer whose initials are not GW come up?
GTW, and that is, you're lucky I don't know what I'm doing. Otherwise, I'd go up there and do it.
Do I have a volunteer to come up and do this? I'm gonna let Javon do it if nobody else wants to.
Well,
right, it's all
Brian,
yours, Brian.
Brian.
It's all yours, here we go.
I can tell. Yeah, they're like kind of short on you.
I know what they are. Not my most flattering moment.
That's
Funny.
It's all right.
See a little
Okay, I'm gonna ask help from the audience. What I do first?
He gonna do the dance with, he gonna split his hands.
Thank you. What, I
No,
don't?
you do.
Nah.
Alright, so that's 8 and 8. Now what do I do? What?
Subtract the two numbers.
I get 0.
No solution.
Yeah, now I don't know what.
Now there's no solution. Can anybody explain how we know there's no inverse?
Because you don't have a thing.
Okay, what do we do with the 0, Jack?
You have to put under all the numbers, so you can have anything.
Exactly. Jack says, remember, when you do your inverse, it's 1 over the determinant, right? You can't sit on the egg. This is not possible. There is no solution. When your determinant turns out to be 0, it means you're not solvable. Okay? Now, in your packet, I want you to turn to the back of page 46. On Monday, you are going to have a graphing calculator. So be sure that you make arrangements to have one with you on Monday. For now, we are on the back. We are on the back side of page 46. And we are going to solve these systems using Cramer's rule. Now, I gave you kind of a glimpse of this yesterday. Was anyone paying close enough attention yesterday to be able to tell me how I get started on this Cramer's rule problem? My objective is to find the answer, the point where they cross. So I will be finding an X and a Y. Julia? I do. So I'm going to find the determinant of just the coefficients. You are going to be expected to be able to do Cramer's rule. So let's start right now paying attention. We're going to do several examples, as much as we have time for. Karen?
Why do you have the Rubik's Cube?
Is that the Rubik's Cube that's supposed to be on my shelf?
Is it?
Thank you, Jabron. Now, what is the value of this determinant?
Negative 17.
I got negative 17. Katie Thomas, your hand was up earlier. Do you know what I do with that negative 17?
Like X equals, then it'll be a determinant over 17 and Y equals.
Exactly. So whatever X and Y turn out to be, they are fractions, and their denominator is negative 17. Remember, I am looking for an X and a Y, just like I do when I substitute and eliminate. Only my X and Y are fractions this time over negative 17. Now, I need to figure out what the numerators are. And as Katie said, they are other determinants. They're going to look like this. Who remembers how I find the determinant that goes above X? Jack?
You plug in the answers by 1 and 2 to...
These guys that I haven't used yet, because I just did the coefficients, I take those guys and I paste them on top of the X numbers. These are the X coefficients. So I'm going to pull these and glue them here. So I will have 1, 2, 3, negative 4. These get pasted right here. So I have 1, 2, 3, -4. And then I evaluate that, right? So when I evaluate that, what do I get? -4 minus 6.
Negative 10.
I get -10 over -17, or 10/17. That's my X answer. Now, how do I do Y?
But do the same thing.
I do the same thing. I'm going to take these numbers and paste them on top of my Y coefficients. So I have 2, 3, 1, 2. Okay, now look, pretend you can actually do this. Cut this out and paste it. So the 2 and the 3 are still here, and now you have the 1 and the 2. What is the value of that determinant?
1.
4 minus 3, that's just 1.
What?
4 minus 3 over -17. That is a yicky answer, but we didn't do anything with fractions. It was easy. We just did regular multiplication and subtraction. Okay? Now why don't you, with your neighbor, give the next one a shot?
Wow, big smile.
You're looking for the Kleenex one, for some reason, Abby.
Neighbor
thinks
from
they
neighbor?
are.
Are you gonna answer?
Okay, so I want everybody busy on this problem.
I thought we were pretty close. I know we're pretty close from our experience last week. It's fine. I saw the light.
Okay, Karen, I don't see a pencil moving on your paper. Well, so you are helping each other, hopefully, figure out B.
So it's 7 over 8. Is 5. Well, how do you It's
Did you get -3 as your denominator?
Yeah.
Now, to find X and Y, we're going to cut this out and we're going to glue it. So we have 7, 8, 1, -1. You should have gotten -7 minus 8, which is -50. Oh my gosh, did you get 5?
Yes. Oh my gosh, Miss Ford.
And then we cut this out and paste it here, so we still have the 1 and 2, but now we have the 7 and the 8. Oh my gosh.
Are you on your bed?
Did you get two?
Oh, so it's 4 and 2? Yeah.
It's 4.
Oh, 4.
Oh, you're not.
For tomorrow,
For Monday.
Monday. Same page as last night, only you're doing problem 2.
Can we have a quiz?
And I have given you the answers,
Can we have a
just
quiz?
like before, so you can check. Problems 2 and 3.
Can we have a quiz on
We
Monday?
may could very well have a quiz on Monday.